All right, my name's Andy. I'm going to be introducing everyone and what we were doing. We are the Network Creation if I can speak, Implementation Specialist, otherwise known as NCIS. I know on your paper that shows the network, it says HAIG. That I just forgot to change it, unfortunately. So it was actually implemented as NCIS. Anyway, what we were asked to do is we were supposed to create a network that consisted of two forests, USA and Europe. Each forest needed to have two domains, east and west. Each of the domains was to have 2,200 users. The USA side was supposed to be the enterprise, so it can control the Europe. I mean, the USA can do things over on the Europe side, like just kind of have administrative control. Also, we needed to set up a trust between the two forests. It needed to be a forest-to-forest transitive trust. To do this, we had to raise the function level of both the forest and the domain to 2003. Our network took advantage of Windows 2003. We were supposed to lay out a design on paper and show it to and it was supposed to be approved by the IT manager, namely pretty much I. And we were also given a list of guidelines to kind of go by to get this all taken care of and put together. Now to introduce our team. First, other than me, I'm Andy. Then we'll have Joe. He'll be explaining routing. He'll also be explaining group policy and permissions. Lloyd, here, he'll be explaining DHCP and DNS. TJ will be presenting WINS and file and print servers. Minerva, here, will be presenting Active Directory. She only has one that's pretty big. And Jason here, last but not least, will be doing backups and offline files. So now I'm going to hand it over to Joe, and he'll let you know from there.
Okay. That was something you're supposed to cover.
Oh, it was.
Yeah, that's okay. It just explains the forest, how we establish the forest trust. Okay. How we envision our network to be laid out is that each domain has two routers connected to two different ISPs for fault tolerance. This is so that, say the connection at one ISP goes down, we still have connection through another one. You know, it's just basically to keep the network up and running, just so if something goes wrong, things are still running. We decided to use OSPF as the routing protocol, which stands for Open Shortest Path First. And the reason we chose that is because the other routing protocol is called RIP, and it only supports up to 15 routers, and our network currently has 12. So, if we count for expansion, we have to change the protocol on the routers. So we just went with OSPF just to make everything implement and work out the way it should without too much administrative effort for growth. Whoa. We implemented NAT, and what NAT does is you have one external IP address that people can get to from the internet, and your inside address structure is completely hidden. And we used a Class B private structure to allow for growth. Let's see. I'll explain the structures as we get into it a little bit. But as our external addresses for the USA domain, we chose 147.147.143, and we gave specific numbers, but it's a project, so it doesn't really matter. But 10, 11, 12, 13, 14, and 15 would be the routers in each domain, and the Europe domain's address is 165.15.47 with the same numbering scheme. We chose a subnet mask of 240 because one of our requirements was to have 22 computers in a network. How you figure that is you have a subnet mask, and on one side can only be ones, and on the other side can only be zeros. So there's a set number of things. So if you want to get to 2,200 host computers, you just start at the far right side, and then you got 2, goes 0 and 1 makes 2, and then got another one, so that makes 4, 8, 16, 32, 64, 128, 256, 512, 1024, yeah, 2048, which is really close to 2200, but it's not quite there, so we had to stick that other bit in there. So, and then 255, then 255. And that's how we got the subnet mask of what it's supposed to be. Let's see. And then our internal address scheme, like I said, we chose the Class B private, which starts at 172.16, and it goes all the way up to the 172.31 network. And like I said, the reason we chose that is for growth. And we also chose it like the USA geographical domain has 172.16, and then the Europe, the other forest, has 172.17. And I chose that method because if we were to, like, say, add an Asia forest, we could just make it 172.18, and then we could start globally going out throughout the entire world just by adding more numbers. And then inside for the domains, we just started with 0, and then went down to 16 and 32. I guess I could do some more explaining to explain why there's 16 and 32. It's okay. This is an octet. This would be .0, and each of these is an octet. Okay? And then on the octet that you're working on, which would be the second octet, which is the one I'm changing here. This is how the networks go up. You got 2, 4, 8, 16. And that's that magic number that Peter taught us, and you guys will be learning about. And how it works is this is called a network ID. That's not applicable for an IP address, but it covers the entire network of 172.16.0.1, which is a host computer, all the way up to 172.16.15.254, which is the last available address before this network. And then in the Europe domain, it just mirrors the other one, pretty much exactly, just incrementing that one. And that's just for ease of administration. You know, an enterprise admin could come in there and say they changed something in the USA domain and they want to make that same change in the Europe domain. They can just, change the second octet number from 16 to 17, and the procedure is exactly the same. And on our routers, we also implemented a DHCP relay agent, which you have to implement on the routing and remote access console. But for DHCP, just so I don't step on people's toes, that's Lloyd over here, and he'll be telling you all about it.